Late at night, when the highways stretch empty across the horizon and the world seems to slow down, certain machines refuse to follow ordinary rules. Most cars on the road are built for practical things: fuel economy, comfort, daily transportation. They move people from one place to another without asking much attention. But somewhere in a quiet, climate-controlled garage sits something very different. A machine that was never built for normal life. A machine created to push the limits of engineering itself. Because for nearly 20 years, one engine dominated the world of hypercars. An engine so extreme that many engineers once believed it simply couldn't exist in a production car. 16 cylinders, 4 turbochargers, and enough power to rewrite the limits of internal combustion performance. This engine powered some of the fastest cars the world has ever seen. Cars that shattered speed records. Cars that pushed beyond 400 kilometers per hour. Cars that forced the automotive industry to rethink what was mechanically possible. But every engineering era eventually reaches its final chapter. And today, that chapter belongs to a car that represents the last evolution of this legendary machine. The Bugatti Mistral. A hypercar that isn't just another high-performance vehicle. It's a farewell. Because hidden beneath the sculpted carbon fiber bodywork lives the final version of one of the most extraordinary engines ever placed in a road-legal car. The Bugatti quad-turbocharged W16. An engine that stands as one of the greatest achievements of the internal combustion era. And understanding how this engine works reveals just how far modern engineering can push mechanical performance. At the heart of the Bugatti Mistral sits an 8.0-liter quad-turbocharged W16 engine. Unlike a traditional V8 or V12 layout, this engine uses a very unusual configuration. Instead of two banks of cylinders, the W16 is essentially built from two narrow-angle V8 engines combined together on a single crankshaft. This creates 16 cylinders arranged in a compact W shape. The design allows Bugatti engineers to fit an enormous number of cylinders into a relatively short engine block while maintaining structural strength and balance. 16 pistons move inside the block thousands of times every minute. Each piston connected to a forged steel crankshaft through extremely strong connecting rods designed to survive enormous combustion forces. Every time one of those cylinders ignites, the explosion pushes the piston downward. That force rotates the crankshaft. And when this happens 16 times in rapid sequence, the result is an incredibly smooth and powerful flow of mechanical energy. But airflow is the real key to unlocking extreme power. To push this engine far beyond the limits of naturally aspirated performance, Bugatti equipped the W16 with 4 turbochargers. Turbochargers work by using exhaust gases to spin turbine wheels at extremely high speeds. Those turbines compress incoming air before it enters the engine. Compressed air contains more oxygen. More oxygen allows more fuel to burn during combustion. And more combustion means more power. In the Bugatti Mistral, those 4 turbochargers force enormous volumes of air into the engine, allowing it to produce an astonishing 1,600 horsepower. That level of output places the Mistral among the most powerful internal combustion road cars ever built. But generating that kind of power also creates an enormous amount of heat. Without proper cooling, an engine producing 1,600 horsepower would quickly destroy itself. To solve this problem, Bugatti engineered one of the most advanced cooling systems ever installed in a production vehicle. The W16 uses multiple radiators and intercoolers working together to regulate temperatures across the engine block, turbochargers, transmission, and intake system. Intercoolers play a crucial role in this process. When turbochargers compress air, the air temperature increases dramatically. Hot air is less dense and can reduce engine efficiency. So the intercoolers cool that compressed air before it enters the cylinders. Cooler air is denser. Denser air contains more oxygen. And that improves both power and reliability. Inside the engine, the internal components are designed to survive extreme stress. Forged aluminum pistons. High-strength connecting rods. A reinforced crankshaft capable of handling enormous torque loads. Every component must survive explosive combustion forces thousands of times every minute. Fuel delivery is controlled by a highly advanced direct injection system that precisely sprays fuel into each cylinder at the perfect moment. This precise control ensures stable combustion while maximizing performance across all 16 cylinders. Press the accelerator, and the entire system begins working together instantly. The turbochargers spin. Air rushes through the intake system. Fuel injects into the combustion chambers. 16 cylinders ignite in rapid sequence. And the result is a wave of acceleration that feels almost unreal. Power flows through a 7-speed dual-clutch transmission before reaching Bugatti's advanced all-wheel drive system. This allows the Mistral to transfer its massive power to the road with incredible stability and traction. Despite being an open-top roadster, the Bugatti Mistral is capable of reaching speeds exceeding 420 km per hour. That makes it one of the fastest open-top production cars ever built. But beyond the numbers, the W16 engine represents something much deeper. It represents the absolute peak of what internal combustion engineering can achieve. 16 cylinders, 4 turbochargers, unimaginable power, all working together in perfect mechanical harmony. And as the automotive world begins shifting toward electric powertrains and hybrid systems, the Bugatti Mistral stands as a final celebration of an extraordinary era. Because engines like this may never be built again. And that's exactly what makes the Bugatti W16 one of the most legendary engines in automotive history.